In this video, we'll talk about hexadecimal numbers. Binary is nice and deep down is the way that computers think about numbers, but binary numbers can be really awkward because there's so many digits to keep track of, and hexadecimal numbers is one way to deal with that. Hexadecimal is base 16. So like base 10 has 10 digits, base 16 has 16 digits. And these 16 digits, we kind of ran out of symbols. So we use the symbols 0 through 9. Wouldn't it be neat if you could make up new symbols for the rest of the numbers? But we don't. We'll just use the letters. So the letter A stands for 10. But you can't like jam a 10 inside one column, so you have to use the letter A. It works the same way as decimal system in binary, where you have columns, and the columns represent, in this case, powers of 16. So if you want to convert this number, 219, in hexadecimal, we see how many 256s there are. Well, there are two 256s. Well, that's 512. There's 116, and there are 9 ones. So what does that add up to? 528 plus 9 is 537. And this E, it might look a little jarring to have a number. The number 4E looks weird, but in hexadecimal, that's legit. And in this case, 4 means that there are 4 16s, which is 64. And E is 14, so that's 78. And I'll just put a little number 10 there. This is converting it to base 10. If you want to go the other way around, we're trying to convert a base 10 number to base 16, which is hexadecimal, abbreviated hex. We have to figure out how many 256. Well, there aren't any 256s in 59, but it looks like there should be, let me see, 48 is the biggest number, right? So that's 316. How many do we have left? 11. So we need to stick 11 in there, but again, you can't jam 2 digits in there. That can be confusing. So you put the letter B, 3B. And the reason why hexadecimal is another wonderful choice to use to represent numbers in computers is because it's related to binary. Let's look at these first digits here. If I had a decimal, let's say I had a binary number 1111. We know that's equal to 15 base 10, right? Well, 15 is the same number of digits. 0 to 15 is what you can put inside the first column of a hexadecimal number. So this particular number here isn't 1011. Let me see, that's 18, 04s, 12, and 11. So that's 11, base 10. So we can just put the number 11 here, and 11 is B, in the first column of the hexadecimal number. And if there were no green numbers, this would be legit. This would be the answer. Hexadecimal is B, and the first 4 digits of a binary number 1011 would be the same. Those would both be the same value, 11. Okay, but you can do the same thing now for the other group of 3 digits. You can treat this just like a group of binary digits, and in binary, 0101 is equal to 5 base 10. And look at the columns. This is the 16th column, and this is the 16th column. So all these numbers tell how many 16s there are. And then all the next numbers and so on tells how many 2256s there are, and so forth. So this group of digits right here can be stuck in the second column of the base of a hexadecimal number, and so you can put a 5 there. So this number 01011011 is the same thing as 5b. 5b is much easier to deal with, and it's pretty easy to go back and forth between hex and binary, so that's why hex is important. So we can do the same thing instead of combining a whole bunch of decimal digits into one column in hexadecimal. You can split it up. A is equal to 10, base 10. So in binary, 10, let's see, 8, 4, 2, 1. 10 would be 1, 8, 0, 4s, 1, 2, 0, 1. So we can put a 1, 0, 1, 0 right there. And C is 12, base 10. And 12 is 1, 1, 0, 0, because it's 1, 8, 1, 4, and that gives us a 12. 1, 1, 0, 0. So the number CA, which is a number, I know it has letters in it, but it's not, those are numbers. CA is 1, 1, 0, 0, 1, 0, 1, 0. You have a calculator on your computer that can do this. Just pull up your regular calculator, and both Windows and Mac have a programmer mode, and the programmer mode lets you either enter hexadecimal numbers and convert between the hexadecimal, binary, and octal. Octal is base 8. You don't see it that much, so I'm not going to go into it, but it's the same thing, just base 8. And so you can work with this. And the reason you do this is because a lot of times, like for example, on web pages, when you specify colors, you can specify colors as a hexadecimal number. This green is 99FF33. And what this means is that the first two digits are the red, how much red is in that color. So like here for red, the first two digits are FF, that's 15. That's the most amount of red you can get. FF is 255. And there's no green and no blue. So it's this RGB. So in this case, 99, the number 99 hexadecimal is 153 base 10. The FF is 255, and the 33 is 51, a base 10. So it's quite convenient. You can end up storing over 16 million colors using just 6 hexadecimal digits. So that's it for the intro to hex. Well, no, let's talk about how hexadecimal works in Python. You can enter values in hexadecimal or binary by just prefixing the number with the 0x if you want a hexadecimal number, and you prefix the number with the 0b if you want to enter a binary number. By the way, you can enter the number any way you want. Python's going to represent that number internally the way it does, and it doesn't matter. You could either specify 0xFF for the number 255, or you could have said x equals 255. It's identical. They work the same. The reason you want to do this would be probably, depending on the application. For example, if you know that x is the amount of red in your color, well, it would be nice for the person seeing that, oh yeah, this is FF. That's because that's from the color codes. There are other operations you can do with binary and hexadecimal operations, especially binary operations, that I'll show in another video.